Good morning, everyone. My name is Rodolfo Eric Angat. I'm your teacher in Earth and Environmental Science. Today, we'll be learning about Barycenter, or the center of gravity. In your elementary years or even in middle school, you have been told countless times that the moon revolves around the Earth, or the Earth revolves around the sun. But studies reveal that it is not really that way. The moon actually revolves around the barycenter of the earth and the moon. And the earth revolves around the barycenter of the solar system. Again, when we say barycenter, what we mean by it is the center of gravity. So let's have this demonstration right here. I created this device so that we would understand barycenter even more. Now, here we have a styrofoam ball representing an object in space. And then another styrofoam ball that would represent another object in space. These two styrofoam balls have almost the same mass. Now, let us find out what is their barycenter or their center of gravity. Okay. Okay, to put there. Okay, you would see here that the center of gravity of two styrofoam balls representing objects in space is found directly in between the two or in the middle because they have the same mass. Now, these two objects, let's say that these two objects here represent two stars in a binary solar system. These two stars, as they rotate and revolve, I cannot show the rotation, but I can show the revolution. Now, these two stars here revolves around their barycenter or their center of gravity. Okay? Now, not all objects in space have the same mass. Some are big and some are small. Let's say we have this, the small ball, the ball here, which has the letter M, represents the moon. Okay? Let's put it there. And then, let's have another ball here. Remove the other ball and get a bigger ball with an E on it, which represents the Earth. Okay, now this here represents the Earth, while this here represents the Moon. Now let us find their barycenter or the center of gravity. Will it be in the same position as in between the two, or closer to the less massive object, or closer to the more massive object? Let's try it here. Okay, it's not balancing. Let's put it to the more, closer to the more massive object, this ball here representing the Earth. Okay, now you would see here that the barycenter of the two objects, is closer to the more massive object, as in this case, in the closer to the bigger ball representing Earth, rather than closer to the smaller ball representing the moon. So one concept that you have to remember about barycenter is that it is always closer to the more massive object. Now, if I remove this from here and show it to you, you would notice that the moon is not actually revolving around Earth. It's actually revolving around the barycenter. It just so happens that the barycenter of the Earth and the moon is within Earth. Okay? It is within Earth. Let me hold it. Okay, right there. You'll see that it's within Earth, at a depth of 1,710 kilometers or 1,063 miles. So I would say it would probably be safe to say the moon revolves around the Earth because the barycenter is within Earth. Now, another concept that you have to notice here is that as one object rotates to another object, wobbling happens. Of course, I cannot really show the effect of the gravity here, not that much, but we do have gravity. But at least it would show you the idea. As one object revolves another object, you will see that Earth is wobbling and likewise the moon. The wobbling is caused by the gravitational attraction between the two objects. And this wobbling is the sign that astronomers use to determine if another satellite or another planet is behind or hiding behind the star or hiding behind the planet. Let's say a moon of Jupiter is hiding behind Jupiter. Even without seeing it, astronomers can determine that there's a moon behind it if they see wobbling, okay, of the planet Jupiter. And this is the same thing that they use to find other planets in the universe. Now, how does that work? Let's say this is a bigger planet or a star, either a star or a planet, that would do as long as it's bigger. And this is another object. It can be a planet or a satellite as long as it is the one smaller compared to the other heavenly object. But as of now, let's say that this is a star and this is a planet. And the planet is behind the star. You don't see the planet, right? It's hiding behind it. But scientists use the wobbling of the star to determine if a planet is hiding behind it. And that's how they find planet. Or let's say this is a planet and this is a satellite. It's hiding also. If the planet is wobbling as it revolves and rotates, then that is a telltale sign that a satellite is hiding behind it. So that is the concept of barycenter and also how scientists find find out if there is a planet or a satellite hiding behind a bigger object like a star or a bigger planet. Okay, so again, barycenter is the center of gravity. Hopefully you learned it. Thank you so much. Have a wonderful day.